Hi everyone. Hello. Bonjour à tous. Good to see you. How are you all? You all enjoyed the conference so far? Yeah, that's good, that's positive. So it's good to see so many people here. Now, are you here because you know a little bit about Typelevel Scala? Or are you here because you don't know anything about it and you just didn't want to go to the other talk? Or some other ulterior motive? Okay, well, there's a lot of people here anyway. Who's heard of Typelevel Scala? So, okay, as in you've heard of it beyond the title of this talk? Yeah? Okay. So, it seems like a majority of people know a little bit about Typelevel Scala. Maybe there's a few people who don't know anything about it. What I'm going to do is talk about the idea, what it is, as a fork of Scala, the language. Lars is going to talk a little bit about Typelevel in general. And then at the end we're going to have a panel. George Dontier is going to join us, and JD Allen from Typesafe will come up and we'll take questions at the end about Typelevel, what it is, how it relates to Typesafe. So if you have any questions, I'm keen to hear difficult and challenging questions. That's a good thing. It gives us an opportunity to answer them. Save them for the end. If I don't explain something very specific, by all means shout out, but I think most of the points I make will be quite vague anyway. Okay, so we're going to start. I'm going to pass over to Lars, who's going to tell you a bit about Typelevel. Lars, go for it. We've got this rather large stage here. I've got to...
Yes, so what is Typelevel? Typelevel has been founded basically by me registering a domain name, and I thought like what would be a cool domain name to have, so I registered at typelevel.org, I think like 2.5 years ago, and it really started off at the Scala conference last year in Philadelphia, where Miles Seddon, Eric Ostheim, Tom Switzer and me got together and thought like, okay, we have these three libraries, Scala, Aspire, and Shapeless, and all these libraries kind of would be cool if they could work together, because some users are already using them. Scala is the largest of them, then it has by far the most users, and Shapeless is also many users, and so we thought like it would be cool if we could kind of get together and see what would happen. So here's kind of attempt at definition. So it's so one of the big points is it's a loose organization, so all these projects stay independent. And it's a like-minded Scala project because we have a common goal, and the goal is that the Scala compiler should do more work for you, so that we shift some of the burden from runtime to compile time, and we want to get at most out of the Scala compiler as we can. So especially Shapeless is known for pushing the boundaries of the Scala compiler very far, and this is kind of our common goal. And we also have a website. So admittedly, there's not much on that website. So there's at least a list of projects, and there's a small blog on there. But you can see at least the list of projects and some short descriptions, which should give an idea of what we're about. So here's some more of the goals. Yeah, so first thing is that Scala, we want to take advantage of Scala's type system. Why we want to do that? Because we kind of see that Scala's type system is unique amongst other languages. So we have object-oriented features, we have features known from Haskell, like higher kind types, and a couple of other things. And we think that we should embrace the new style which arises from that. So we don't just want to do Haskell style programming, we don't just want to do Java style programming, we want to take the best features from both worlds and kind of try to combine them and see what we can achieve with them. Also, we want to allow these projects to work seamlessly together, as I said in the introduction. So one of the immediate outcomes of this Typelevel, let's say, umbrella was that there's now a couple of libraries called contrib, so Shapeless contrib and Scala Z contrib, also Spire contrib, and they are kind of bridging between different libraries. So we have conversions between concepts in these libraries and stuff which should allow you to use those more seamlessly. And the newest addition to that family is SBT plugin, which is called SBT Typelevel. And this includes some features which should allow you to pull in these dependencies even easier and automate some tasks with respect to releasing, and it tries to define some common guidelines of how to produce a high-quality Scala library. Also, the third point, which is very important, we want to create an open and welcoming community, and we want to invite contribution from everywhere. So we are not seeing ourselves as a closed kind of community, but we're really trying to get as much input as possible. And this becomes especially important for our Scala fork, but Jon will talk about that. So,
no, carry on. Sorry, this is still your slide.
Yeah. So I already mentioned it. So ScalaZ is probably the biggest project inside Typelevel. Probably all of you have heard of it. So this is like this library porting, Haskell's, Prelude, and some other concepts to Scala. Also giving concurrent programming. Also giving effectful programming, safe effectful programming. Then there's also Shapeless. Shapeless supports generic programming and generally pushing the boundaries of the type system to what could happen. And this was initially, so I'm not sure how many people of you heard of Scrappy Boilerplate, which is it was a milestone paper in the Haskell work for generic programming. In Miles 7 started from this paper and tried to encode it in Scala, and from then on we got a lot more stuff. So for example, we now have type class generic programming, so we can say what is a type. We can abstract our type classes. We say what capabilities does a type class support, and then we have arbitrary case classes, and these arbitrary case classes can then get instances for free. So there's some other resources I won't go into detail, but basically if you have a suitable library, you can just define any case class, and you don't have to implement the type class instance for that, because Shapeless does it for you. And that's really nice. And that's also one point where the collaboration is really important, because Scala that defines type classes, and Shapeless defines means to abstract our type class. So that's a natural fit together. Then we also have Spire. Spire has been started by Eric Osheim and Tom Spritzer, so there was at Scala Days 2012. Eric made a presentation about a new or improved numeric stack for Scala, and then he went on and implemented it himself. So you have fast and efficient numeric programming and a lot more. So you have new data types for numerics, and you have matrix operations and more. So basically your one-stop shop if you want to do anything with algebra or numerics. So this is also important because I said initially that we have some common goals, but we don't necessarily have common design guidelines. We believe in principle in Scala library design, but we also believe that Scala doesn't lend itself to one true principle of software development. We just want to say that we're trying to explore what could be the principles. So, for example, Spire and Scala have very different philosophies. I mean, Spire itself uses type classes very often, but Spire, for example, says we allow type classes which are not really lawful. So, for example, in Spire you can work with floating point numbers just fine, whereas in Scala set we say we don't want floating point numbers because we get rounding errors, which makes our abstractions, which break our abstractions. And in Spire, it's just fine. It's like, okay, we can do that because we shift our focus not on the purity of mathematics, but we shift our focus on actually doing work with numeric numbers. And we have to deal with floating point numbers, so we have to acknowledge that. So as you can see, all these different projects kind of there is a variance of what principles we have. Then there's another list of projects which have been more recent additions. So, for example, Stacks 2, the testing framework, and also Scala Check, which is probably well known. And Scala Check is also a very nice example because it uses type classes and it also implements a well-known concept from Haskell in Scala. And then we have scodec, which is for binary serialization and deserialization. And we also have Scala for Screen.
Just a question, Lars. Are there any Typelevel projects that don't begin with X?
Yes. So recently we have added some more projects. So Organaut is for JSON processing. Discipline is for law checking of type classes of your library, and you define your own type classes for whatever you have. And you want to write Scala check tests to test your instances, then you can use Discipline. And also Monocle, which is optics for Scala, and this means basically purely functional state updates in your code.
Okay, I think I take over here. I'm not certain because we only put this together about 6 o'clock this morning because I was driving over from Belgium last night, got here at 2 AM. This is the first time Lars and I have seen each other for several months. So let's see what the next slide is. I'll have to keep checking to see what's up next, and then I'll talk about it. It's lazily evaluated presenting.
Also something we took from Haskell.
Okay, so we have this fork of Typelevel, which Miles had announced probably 6-7 weeks ago now, which is a branch from the mainline Scala, and it's designed to be experimental. It's designed to have generally lower stability and quality standards than the mainline Scala compiler, which allows us to experiment more, to try out new features which may work, which might not work. And I've called it a playground there. I hope it will be a playground where we can try things out, and we expect to have some failures along the way. But we'll see what happens. It might be that everything we try we get right first time, but that's not particularly likely. The stability requirements for Typelevel Scala are not as strict as Typesafe Scala. That's a key point, and it's an enabler for us, because it means we can break binary compatibility between versions if we want to. We can experiment with that. We can introduce features which we don't have a long-term plan to support. We can see how that works out, and it might be the case that those features are used by users. It might be that the Typelevel projects, which will be the primary benefactors to begin with of Typelevel Scala, it might be that they start using those features and we find we can reduce the amount of code, the amount of repetition in those libraries, and also in other people's code that uses those libraries. And if that's the case, then it might be that feature is considered a good thing and it stays. And we expect a faster rate of change. We expect stuff to break more frequently. Now, I've been using Scala quite a long time, and I remember what it was like 5 years ago or 8 years ago. And stuff did change very frequently. As a consequence of that change, stuff broke as well. And we dealt with it. We had ways of dealing with it, but we couldn't rely on developing for one version of Scala, say version 2.2, and expect that code to work unchanged on Scala 2.3 or whatever version is around in a year's time. In a year's time from 2.2, it was probably version 2.6. Things were moving faster because there was a smaller community. It was more nimble in many ways, and it had this ability to adapt without breaking too much code, without breaking production systems, enterprise systems that a lot of people are relying on. So Typelevel Scala is a shift back to that. So we're accepting things will break. We're expecting unreliability and lack of stability to some extent. But that will enable us to develop faster, we hope, and introduce new features and hopefully more wacky ideas. And we'll see what happens. There's a few ideas on the table at the moment. And in the long term, what I hope is that features will be able to move from Typelevel Scala to Typesafe Scala, so from our fork to the version of Scala you're familiar with, and back again. So when Typesafe introduce new features to mainline Scala, we will pull those in. We will remain merge compatible with Typesafe Scala. But also, if we have a feature that we've implemented that works and works demonstrably in Typelevel Scala, that's probably a good candidate to move into Typesafe Scala if it fits with stability and the robustness guarantees that Typesafe Scala provides. It might take a couple of years to get there, but what that means is that when that feature arrives in Typesafe Scala, it's been tested. It's been tested extensively in Typelevel Scala. People have used it. They've used it in the wild. They've experimented with it. They've discovered things that might not be discovered if it were put straight into Typesafe Scala. Now, the risk for Typesafe developing new features is that if it gets put into a release version, say Scala 2.12 introduced Typelanders. Typelanders is a feature I'll show you a bit later on. But say Typesafe Scala introduced Typelanders, they maybe work fine for the first month, and then someone discovers a small problem, which means that the whole idea isn't quite right. But there's already people depending on that code in production. And that needs to be, that code then needs to be supported. Or, and to remove it, which is what Typesafe may have to do, given some feature that's got into the library. And this is something that's happened before. Features exist in Scala now that shouldn't really be there. But they're impossible to remove, or it's a very slow process to remove them because people using them and depending on them. So say Typelevel got used, it would be probably 3 years before they'd be able to be changed or removed. Because Scala 2.12 introduces them, by Scala 2.13, and we're probably looking at late 2015 now. I think that's right, Union? Yeah, so late 2015, Scala 2.13 comes out. Yeah, question?
So my question was related to what you just said. Do you plan to remove stuff from Scala in Typelevel Scala, or you plan to just extend the language?
So, okay, yeah, so I will, in fact, Lars will talk a little bit about compatibility. We are planning on both adding features and removing what Brian McKenna would call warts, but removing things that we don't like in the language, that we think the language would benefit from not having. But we've got a few slides on compatibility there. So, yeah, if this new feature's introduced, it's Scala 2.14 before it's actually gone away. And for the whole life cycle of 2.14, we will probably still be maintaining 2.13 code. So it might be 2018 or 2019 before that feature, which was introduced in Scala 2.12, actually goes away, the feature we shouldn't have had. Hopefully, the Typelevel feature will be experimented with extensively in Typelevel Scala first. And we'll be confident when it goes into, hopefully when it goes into mainline Scala, that it does work, and it works in the right way. And we're not left with a horrendous legacy that lasts for years and makes the program experience worse. So why are we doing this? Why did we decide to fork Scala? It's a good question. What's the answer? Okay. So we have different interests from Typesafe. Typesafe is a commercial organisation. It has customers, and it has a version of Scala which is used by people who care a lot about the stability of the language. They want to rely on it. They want to be able to confidently say, developers want to say to their managers, we're using Scala, it's backed by Typesafe, they're putting money into this language, and they're going to guarantee that it will work consistently, it will be robust, and that the versions will be maintained for years to come. Now that's a very useful thing, and we're fully appreciative of Typesafe for the finance they've put in and the developers they're contributing, the Scala C development team, who are doing an extremely important job. Without that, we'd be back in 2006, where the compiler broke every new version. And I remember that, and it was painful. So we're getting a huge benefit from Typesafe. But that consequently means that we can't add new features as easily as we could before. We can't create breaking changes. It becomes more difficult. And I hope that the Typelevel projects will benefit more from the kind of features we're adding. And they are very much aligned with the Typelevel philosophy, to get the compiler to do more work for us. So, I mentioned before we've got some wacky ideas. This is our opportunity to do them, and to try them, not just in our own private fork. I mean, that would be a possibility. We could develop a new feature and try it out for ourselves and our own projects, but it would be hard for somebody else to depend on our fork. So we're hoping to get an ecosystem around Typelevel Scala that has critical mass, where we can throw out throw wacky new compiler ideas into the wild, get people to use them, experiment with them, find bugs, and create code or create a compiler that has these features implemented in a way that there is more robustness and stability than there would be if we'd been doing it by ourselves. We want to see the language open. We want to see input from lots of different people. It's without this fork, it's difficult for somebody to create their own new features, their new experimental features, and have them tried out by lots of people. So we want it to be open, and we have a much lower threshold for what we will accept into the compiler than Typesafe do, for very good reasons. And hopefully we'll see more varied ideas. We'll see some interesting suggestions implemented. We don't really know yet. We've had a lot of suggestions. We've had a lot of discussion around those suggestions. But currently, it remains to be seen what actually is workable, what gets implemented, what gets put into the compiler, which pull requests are accepted, and how long those new features last. They may have a very short lifespan, but it will be a moving target. So how did we get here? So why are we forking rather than taking a different approach? Well, what happened was we were in, so myself, Lars, Miles Sabin, and Eric Hosheim, we went to the FlatMap conference in Oslo, which was a very, very good conference. And after that, unfortunately Lars didn't come with us, but Miles and Eric and I hired a car, and we did a road trip across Norway. And over the course of this road trip, you can imagine like three type-level programmers in a car. It's almost the start of a joke. Yeah? Three type-level programmers in a car. They start up in Oslo, and by the time we got to Bergen, on the other side of Norway, we had talked at length about the state of Scala, the state of the ecosystem, features we would like to see in Scala, how realistic we thought it would be that those features could actually get into Scala, and we decided actually some of those ideas were a bit crazy, a bit experimental, and it would be really difficult to put them into Scala. So by the time we got to Bergen, we'd sort of analysed the state of the world, and decided there were a lot of things we wanted. A lot of things we wanted to see, a lot of change. And then in Bergen, we did one other thing. We did do a little bit of tourism as well. It's a really nice city. But Miles and I planned our talk that we did at Scala Days in Berlin. So that was planned. That was planned there. And then on the way back, we took what we had discussed on the way, and we came up with a plan to actually create a fork of Scala. And then we thought about it initially as what would happen if we forked Scala. So we said, okay, well, maybe that depends on the fork. It depends how aggressively we fork, how easily we diverge from Scala. And by the time we got back to Oslo and got on planes to various places we were going, we'd come up with a vague plan. And after that, we spoke to a few people in the Scala community, in Typelevel and elsewhere, who we thought might be interested in the idea, interested in contributing. And we developed that plan, we refined it, we took input from other people, and we came up with close to what we've got today. Now, policy, who knows what this is? So, policy is the fork that came out about a week after Typelevel's fork.
Well, it has been in the version for a long time, but fork basically prompted the release of that fork.
Yeah, so we forced Paul Phillips we forced his hand to use a gambling analogy, maybe appropriately, and he announced policy, which is his fork of Scala. He's done a lot more work on it, and we spoke to Paul at length. He knew what we were up to, and we discussed it with him. He's very helpful. But Paul has been amazingly willing to give his time to us to help us work with the compiler. But policy has different goals from Typelevel Scala. Policy isn't interested so much in compatibility. And while Typelevel Scala is working today, you can run a version of Typelevel Scala, you can run the nightly builds. It works, it has a few features, it's not particularly different from Scala, it's got a few new features. Policy has had a lot more work, and it'll be a long time, I think. Paul may, I invite Paul to give me a different opinion, but I think policy will be longer before it's a usable compiler. And it's altogether more ambitious. Paul has some great aspirations to develop policy into what is probably going to be a different language from Scala. Don't know yet, because Paul keeps his cards close to his chest. I hadn't planned any of these at all. No, seriously, I haven't. But he's planning something more ambitious, and ultimately it might be a better language, but not yet. It'll be a while before we get there. So that is policy. We're going to keep an eye on policy, see what it does. I chat to Paul occasionally, and he's continuing to be very, very useful and helpful to us. So we're really grateful for that. So I'm going to hand over to Lars now, who's going to talk about compatibility.
Yeah, so what Jon said, so policy is going to break compatibility pretty soon. I mean, it already broke it. And we are taking a different stance. So we want three kinds of compatibility: binary, source, and semantic. And I think those are mostly self-explanatory, but just for an overview. So basically the idea is that if we compile code with Typelevel Scala, it will be compatible with Typesafe Scala, so we can still link different binaries together. We hope that this might lessen the initial hurdle of using Typelevel Scala, because if we have semantic compatibility, if we have binary compatibility, we can just link two different modules together and it will still continue to work. And this is basically automatic because the folks at Typesafe have already introduced binary compatibility for Scala major releases. So if 2.11.2 is compatible with 2.11.1, for example, and we can just use the same infrastructure for basically ensuring our compatibility. So that's a very good point, and that's also something we're thankful for Typesafe because they've made all the work and we can use it basically. The other direction might be a little bit harder. So if you're writing code in Typesafe Scala and you want to call out to another library in Typelevel Scala, which is some advanced features, it might be a little bit more complicated. And it's the same way as if you want to call Scala from Java.
So I was just going to give an example of that actually. It's a really simple example. Typelevel Scala allows you to use currency symbols as identifiers. Now this was a particular annoyance for me because I've got a British keyboard which has a load of symbols on it, and they all mean something apart from the pound sterling sign. That is an unused symbol on my keyboard. It's the only one that's available to me if I want a completely unoverloaded symbol. So I added this feature to allow currency symbols. Now you can compile them in Typelevel Scala. The code you get will be compatible, but if you use that identifier from Typesafe Scala, then you need to put backticks around it. It'll work, but it's slightly harder.
Yeah. So it's probably we're not talking about the difficulty of calling a Scala Z from Java, but something like it might be slightly annoying. Yeah, but much less prevalent. Source compatibility means that if we have existing code, we try to make it still compile in Typelevel Scala unchanged. We hope that we can achieve that, although it's a little bit difficult if we change something like inference or type checking or whatever, then it could break, but at least we're trying to stay faithful here. And the question is how we can actually deal with these things. We just have feature flags, and the Scala mainline compiler has already -x and -y, where y means more experimental and x means not so experimental, but I'm not sure. And we have -z, which can be seen as extremely experimental. Don't try this at home. And so we have like explicit implicit type ascriptions. So one feature is that if you declare an implicit value, you need to specify its return type, otherwise it won't compile. And this is not like if you want to use everything, you can use that omnibus. This doesn't actually exist right now.
I think it's pronounced zombibus.
That sounds surprisingly similar to zombiebus.
Yes, it does.
Yeah, you can interpret.
I think it was Eric Osheim's idea.
Yeah, that doesn't surprise me. You can interpret it in the way you want to. And also semantic compatibility. So if we compile code with two different compilers, they should produce the same program for some definitions of same. Basically, meaning about semantics.
We do have a definition of same, and there's a binary compatibility document which details what same means, and it covers all the source and binary compatibility as well.
Yeah, and all inputs should produce the same outputs as for Typesafe Scala. So this is, yeah, it's difficult to achieve, but we will try our best. And yeah, as already said, all incompatibilities which will arise will be put behind my set flags. So that when you're reading some source code and seeing the build file, you will always see what kind of changes there could be. I think we are running a little bit out of time, so we might skip over this section.
Well, I'll say we've got some infrastructure. It's all been set up. We're grateful to, in particular, Alois Koshar, who set up Jenkins build server. All our changes get built automatically, and we get told if they don't work. So current features. Let's very quickly go through this. Shall I do this bit? This is getting to the point where we did much less planning. So there are a few minor parsing tweaks. For example, the currency identifiers, allowing primes like a quote symbol on the end of an identifier. These are really minor annoyances that don't affect most people, but Miles in particular wanted primes. I wanted the currency symbols, and they're not big changes. Singleton type literals. George has done a huge amount of work on the SIP for Singleton type literals, and are we going to do a demo? Have we got time for that?
Yeah, sure.
How long have we got?
10 minutes?
10 minutes?
I think
We'll do a really quick demo of that. So, George will talk about Singleton type literals. So we're going to run the Typelevel Scala.
It has pretty colors.
Oh, yeah. Can everyone see at the bottom there? We should have a REPL that works in reverse. That would be a great feature. Then we could always have things appear at the top. Can someone open an issue for that on Typelevel Scala? Create an issue, REPL in reverse, and we will influence it. Yeah. So the new feature is that you can type 42.type. 42 is the integer, and by placing .type, that becomes a singleton type, which only has one possible member. Do you want to say more about this, George? You know more than I do.
Yeah, so it's a very simple idea to have singleton types. It's basically a type which only has one inhabitant, in this case 42 is the only inhabitant, and if you want to change it, for example to 4, it will not compile, because 4 is not an inhabitant of that type. It's a very simple idea, but it actually opens a lot of possibilities. I'm not going to go into that because I don't really have a lot of time. But
I think one thing worth mentioning is that it allows you to infer implicits
yes.
based on a singleton type rather than a very generic type.
this is super powerful, and Miles is already using that with the help of some macros to generate those and to create what he calls records, which is basically an H map. It's very powerful.
Okay. So the other, if we can switch back to the presentation, the other major feature that is in Typelevel Scala is type lambdas. So anyone who's had to write a type lambda will know that the syntax is really quite horrible. I mean, it's standard Scala syntax. It's been coerced.
Well, it has been discovered as regular.
Yeah, so it was discovered that you could write a type lambda using like 2 sets of different parentheses and writing the word type lambda of x equals something, and then do a hash lambda at the end, and it will give you a type lambda, but that's such a horrible syntax, and it's so unintuitive, and the lambda parameter appears both at the start and the end. It's not pleasant to use. So we've got much nicer syntax, which I won't show you, but it looks a lot more like a function lambda. So anyone who's familiar with function lambdas should get a good intuition as to how type lambdas work.
And that's a really nice feature for Scala Z, because we're using type lambdas all over the place, and it's not very pretty to read, and it makes it harder for people who are not familiar with this kind of programming construct, kind of advanced programming constructs, to read Scala Z source code. And if you have this type level lambda syntax, then it will get much easier.
Yeah. So we've got some future features listed on the issue tracker. Now they're there for discussion, and I would really like everybody to have a look at the issue tracker, see what features are listed there. There's a few of them. I'm going to very quickly just list them on the screen now. I won't talk about them in detail, but those are that was just a selection that I picked out from the issue tracker. There's probably about 50 open issues now, I think. A lot of them, there's nothing more than discussion, and we're working out how the features should be implemented, what the user experience should be like. And please join in, and we're very keen for people to contribute. Working on the compiler, this has been repeated to me by basically everybody I've spoken to who does work on Scala C, but it is difficult. It is a really hard task, and we won't find it easy. And certainly myself, Miles and Eric probably have more experience than I do, but we have very little experience working with Scala C. So it's very much a learning curve. And we're very grateful to the help from people like Jason Zhao, Paul Phillips, and Grzegorz, who have helped us already. But we'd love more people to join in. And don't feel intimidated, because we're not intimidated, even though it is a really difficult task. If you think there's something you can contribute, please join in. And it doesn't have to be code. It can be documentation, discussion, bug reports, especially bug reports, we're keen on them, and feature suggestions, and just discussion. So the roadmap. We don't really have a roadmap. We have what I've told you is our roadmap so far. So we'd like to get a release before the end of the year, and then after that, roughly quarterly milestones. But this isn't set in stone. This isn't definitive. I would love discussion on what the roadmap should be. I sent a mail to the Typelevel mailing list a couple of days ago saying, here's a suggested roadmap. It took me 2 minutes to write down an email, and I didn't get any complaints about that roadmap. We're very open to suggestions. So if you think we should be releasing more frequently, if that would be beneficial to you, tell us, and we will try to accommodate. So that's what we've got in terms of the slides. I'm going to open. Tomer's already got a question. I'm going to invite Jamie up, and George, put some chairs here. And Jamie's from Typesafe. If you don't know him, you ought to know him. It's a good person to know. And we'll take questions on type level, relationship with Typesafe, life, universe, anything that's that you think might be vaguely relevant. So Tomer was first. So go for it.
Putting on my working in Scala in my day job and getting paid for it by a company hat. What would you consider to be, like, as an engineer, I'm definitely interested in some of the improvements that the Typelevel compiler will end up having. But if I ever want to use it as part of my day job, as opposed to as a, shall we say, hobby or anything beyond that, I'm going to have to give kind of an elevator pitch to my CTO,
Sure.
currently, whatever.
So my short answer is, did everyone at the back hear the question? Nobody said say they didn't hear it, so I'll just answer. My answer would be, treat it as you would have treated Scala 5 years ago.
So don't use it.
So I used Scala 10 years ago. You can judge me by that. Lars, you were using it certainly 5 years ago, I think. Yeah, so judge Lars by that. Jake, I think you're using it 5 years ago, weren't you?
Yeah, 5 years.
Yeah. So we thought it was okay to use it then, but maybe we were young, naive, gullible. We were taken in by Scala.
But it was probably a hard sell to
It certainly was.
customers.
Absolutely, yeah. 10 years ago, we just couldn't sell it. If I told my customers that we're using this language called Scala, they'd run away. We had something with Java, and they just hoped they didn't have a look at the code. It kind of worked a little bit.
So there's also, Oderski, you're writing another compiler, I can't remember what it's called, Dotty. And I like this whole idea that there's an advanced feature, a very advanced feature, but with Dotty you get the impression that it's going backwards a little bit. So I'm kind of worried about that a little bit, because I like this language which has very advanced features that I can learn something about, which make programming interesting. And that's why I like to use this. And I would like to know that there's a future in these advanced features moving on. So what I'm worried about, I might have misunderstood, is that Dotty is going somewhere else. How does that fit into the whole picture?
So Dotty, is the dependent object typing compiler that Martin is putzing around with, and it's not necessarily where Scala is going. It is an experiment for him, and it's not that Scala version 3.0 or whatever the future holds is going to be a complete rewrite of the compiler. It's more likely that you're going to see the features in Dotty morph into the existing compiler. Would you say that's fair, Julian?
Yeah.
Yeah. So, and a lot of that has to do with, we don't want to end up in a Python position. We don't want to have a Python 2.7 plus a Python 3.0, having to deal with both of these out there. It's more going to be a progression. So Dotty is going to influence the compiler over time.
Yeah, and as for the development of type-level Scala, we are basically not taking Dotty into account right now. There's certainly we certainly acknowledge that it exists, and it's even in I think it's even in the announcement blog post. I think Dotty is mentioned. But so far we are not taking any. We might take some ideas into type-level Scala before Typesafe Scala does, but so far there are no plans yet. But that's again a point for discussion. So if you see something in Dotty that you would like to use right now, then please open a ticket.
Dotty will type check, but it won't compile code. So it'll
compiles. It actually, since 2 weeks ago, it compiles Hello World application and produces bytecode, as far as I understand.
That's news to me. It's good news. So the Dotty compiler will type check the entirety of the Dotty source. So which is, you would imagine, a reasonably large project. So it's capable of doing that. There was a question over there.
Oh, yeah.
I think we'll have one more question after this one.
Okay, actually I have several questions, but sure.
You get one. Make sure it's the right one.
Okay, does it work nicely with ScalaJS?
Yes, it does, so far. Because I know that the changes we've made so far don't affect, or really shouldn't affect anything, any of the later compiler phases that are particular to ScalaJS. Is that safe to say, do you think, Lars?
Unfortunately, I have little to no clue about how ScalaJS is implemented, so I can't speak with authority. What we're doing right now is mostly we're affecting anything which comes up to and including the typer. So, and if ScalaJS hooks into compiler after that, I think you're safe. Right?
I think ScalaJS happens quite late in the compilation. It does compilation in full, and as a side effect of compiling Java class files, it will produce JavaScript as well. So that ought to continue to work. I don't see anything yet that wouldn't work with that. We're certainly not changing anything in the back end. You might also wonder about Eugene Bamako's new macro, Scala Meta. We've been talking to Eugene about that, and he thinks it's possible for them to work with Typelevel Scala as well, in much the same, for much the same reasons as Scala JS does. So we said one more question. If there is a question, you might get. Oh no, Julian's got a question.
So when
just break the mic.
Oh, I need the microphone. You have a question? So when can we expect the first pull request on Scala for a feature that's implemented and proven in Typelevel Scala?
Good question. So if we were going to make something for a 2.12, I'm going to ask the question back to you. If we wanted something to get into Scala 2.12, how late could we leave it?
Well, I guess the traditional answer is until the first milestone before the first RC, so let's say milestone 8. I can do n for n, less than last.
So so there's another question as to what the first pull request will be. The first significant one. The first significant one I think will be typelanders. Of course, they're actually implemented entirely in the parser. It is just a parsing transformation. So all that horrible code you used to have to write before, that's still there. It gets the new typelander code gets transformed into that in a reasonably straightforward and predictable way in the parser, which is one of the earliest phases of the compiler. So everything after that works as if you had written the longhand version of those typelanders. So this I hope is a feature that doesn't have too much of an impact on the rest of the language. So maybe spring next year, first quarter next year, we could send a pull request over.
Excellent. Looking forward.
Sorry?
Looking forward.
Okay. It'll be up for Eric Osheim, this is his implementation. But I think we're out of time now. Is that fair?
Okay.